I wanted to do this video about factoring trinomials where a does not equal 1. Here is typical form of a quadratic that you can factor. And of course we've discussed how this is the form that it needs to be in. This exponent here of the middle term needs to be half of the degree of your polynomial here. So 1 is half of 2, therefore that's in the correct form to factor a trinomial. And you can have a 4 here, and if there's a 4 here for your degree, then there has to be a 2 here. You can even have a squared term here and a squared term here. You could have x squared and y squared, and in the middle you would have xy. So there's lots of different combinations of variables that you could have, but this middle variable, or variables, there could be two, their exponents have to be half of the exponents of the first term and the last term, if the last term has a variable. Okay, so there are many ways to factor trinomials, but the two ways I'm going to focus on are grouping and an algorithm that's called bottoms up. Most other instructors that I've spoken with, they prefer the grouping method because it's really the most mathematical. The bottoms up method is a method that works if you remember to do it correctly. And that was the biggest complaint that I had gotten from a colleague of mine, is that students use bottoms up and they don't mind, but they forget to do it completely, which then means you have factored incorrectly. One tip that you should always do is make sure to multiply out your factors that you've created from factoring to make sure that you've gotten the correct answer. Okay, so I'm going to do this first example, 2x squared plus 11x plus 15. I'm going to factor it by grouping first, but I still start the same way every time. I name A and B and C. It's important to remember that you're trying to find factors of A times C, so you want factors of 30 that will give you a sum of 11. So even when you're doing by grouping, you need to factor this way so that you can find the two factors that are going to replace 11x. Well, hopefully you know your multiplication facts well enough that in your mind you think positive 6 times positive 5 is 30. Positive 6 times positive 5. And then 6 plus 5 is 11. So those are the factors that work. So if you're going to factor by grouping, you are going to replace that middle term, 11x. You're going to replace 11x with a 6 and a 5. So you're going to keep your first term, 2x squared. You're going to replace 11x with 6x plus 5x. And you're going to keep that last term of 15. Now, I haven't done anything crazy or not understandable. This is still equivalent to this. 6x plus 5x is 11x. And you still have 2x squared and you still have 15. So nothing really crazy has gone on. It's something that you should easily be able to understand. And now if you've learned what to do when you have 4 terms, then this should look easy to do. If you have not, then when you're factoring by grouping and you have 4 terms, the first thing you do is group. You group the first 2 terms and the last 2 terms with parentheses, and you want to put an addition sign in the middle. And then what do you do when you have a group and you're factoring? You look for the greatest common factor. So the greatest common factor here is 2x. 2x squared divided by 2x is x. 6x divided by 2x is positive 3. Then you look at your second group. What's their common factor? Well, they have 5 in common. Positive 5. 5x divided by 5 is just x. 15 divided by 5 is positive 3. Now, this should look like there's a pattern or a coincidence happening. Sorry about that, I'm trying to get a colored pencil. If you look at this, hopefully you notice, first of all, before I start highlighting, when you look at this expression, hopefully you see this is a binomial. 2 terms separated by an addition sign. These 2 terms have a common factor. That common factor is x plus 3. See, the first term has x plus 3, and the second term has x plus 3. Okay, so we're going to factor out the greatest common factor. Okay, so the greatest common factor is x plus 3. When you remove x plus 3 from this polynomial, what's left? Well, let's cover it up. If you take them away, if you take away the x plus 3's, hopefully you see over here on the left you have 2x left, and on the right you have plus 5. So here, beside of x plus 3, you put 2x plus 5. Now, let's check that mentally. X times 2x is 2x squared. X times 5 is 5x. 3 times 2x is 6x. 5x plus 6x is 11x. And 3 times 5 is 15. So I have factored that trinomial correctly into a product of 2 binomials. This is my answer. Factor completely 2x squared plus 11x plus 15. This is the answer you get. Now, how do we do this by using that algorithm called bottoms up? We're going to use the algorithm bottoms up. Okay. What are we going to do? Well, we're going to use that same table we made earlier. Factors of a times c, sum of b, and we're not going to change those factors. It's still 6 and 5. Then you're going to put your 2 binomials being multiplied. You're going to use your middle variable x, and then you're going to put positive 6 and positive 5. And laundry's going right now, so that's the noise you hear in the laundry room. Okay, so positive 6 and positive 5. Okay, now, most students who factor this way stop. This is what they put for their answer. But I want you to look. X times x is x squared, not 2x squared. X times 5 is 5x, and 6 times x is 6x. When you add those together, you do get 11x. But then 6 times 5 is 30. So that's not the correct answer, because when you multiply these 2 binomials, you get x squared plus 11x plus 30. Okay, so that's where this name bottoms up comes in. When a is not 1, once you put these 2 factors here, then you place a underneath both of those factors. So that's what you do first. After you get your factors, place a under the factors, then reduce. So 6 over 2 will reduce to 3 over 1, and you don't have to put the 1 if you don't want to, but I want to put it on this first example just to show you. And then 5 over 2 won't reduce, so I'm going to just bring it down for the moment. Once you get used to this process, you just go ahead and do the bottoms up. And then here's where the name comes in for bottoms up. I'll write bottoms up here. You take the denominator of each of the fraction or the bottom, and you take it up as a coefficient beside of the x. Not outside, but beside the x. The denominator of each of these fractions becomes the coefficient. So in this first one, I've got 1x plus 3, and I have 2x plus 5. And if you'll notice, I have the exact same answer here as I have over here. So both methods work. Most students prefer this method, but I can honestly tell you that most students who use this method, not most, that's not correct. Many students who use this method forget to do the bottoms up portion and stop here as their answer. Students who choose this one, and believe it or not, I have a few who choose this one, they like this, unless they make just a tiny computation error, they get it correct every time. So choose wisely as to which method you want to do. In the next several examples, we're going to do both methods. So here's we go on to example number 2. It looks different though, looking at example number 2. You've got 6x to the 4th minus 39x squared minus 135. Okay, so even though it's not in quadratic form, I can still call this A and B and C. And notice B is negative 39 and C is negative 135. Okay, so I need to make my chart. A times C, sum of B. And I could do that in my head, but I'll just use my calculator. 6 times 135, that's going to be negative 810. And then negative 39 is the sum I want. Now let me speak just for a minute about this. Remember earlier I was telling you that in order to use bottoms up, it has to be in the correct form. Well look, this exponent here is half of this exponent. So this problem is in the correct form that you need to use to factor trinomials. Okay, now let's go to the task. A lot of students who struggle with finding the factors, if you need to, you don't have to, if you need to, write down every single factor. Of course, one has to be positive, one has to be negative. Now let's talk about this so you can do this wisely. I really don't need this pair of factors, although I know it doesn't add up to negative 39. I need for my larger number to be negative because I want my sum to be negative. So 1 times negative 810 would be the closer of the two of these pairs, but of course when I add this together I would get negative 809, and that's not what works. For those of you that struggle with multiplication, just go through your like here's my calculator. Just go through and take 810 and divide it by 2 next. And that would be 405. So that 2 times negative 405. I have students that they don't understand how to get these pairs, and just use your calculator. Take 810, and if you don't know the little trick that I've probably told you in class, and divide it by 3, and it does divide by 3. Whoops, you can't see that. It divides 3 times 270, so 3 times negative 270, and none of these, of course, have given me my correct sum that I need. And you just keep using your calculator if you don't know the little divisibility rules. Just keep dividing and see that that one doesn't work. Divide again. That one does work, 5 times 162, but I definitely haven't found negative 39 yet. So then I'm just going to continue until I find the pair of numbers that would give me negative 39. Look, there's 6 times 135. Of course, I'm putting a negative on the larger of the two because I want a negative product and a negative sum. Okay, let's do 7. And of course, some of you will know that numbers won't divide evenly into it, so don't do those.